Implicit differentiation, okay? All right, so let's look at two equations here. Let's say that we've got x squared plus 3y equals 4. Okay, so we have that one. If I solve that for y, I would have y equals 4 minus x squared divided by 3. Okay. Now they're the same equation, okay, except this one is explicit, this one is implicit, okay. Explicit just means that y is explicit, all right. Explicit, when you hear that word, what do you think about? I don't know, but it's just out there, okay. So y is all by itself, okay, if it is explicit. So that everything we've done up to this point as far as derivatives has been these type of equations where it is a function and y is by itself, and we just take the right side, we say the derivative of y is the derivative of y, and then do the other side, okay? This is in an implicit form. That is where y is not shown explicitly, okay? So if it's implicit, we still can do differentiation with it in this form. Now, this one we could take and solve for y and get a function, if y is a function of x, and then do our normal steps over there if we wanted to. What if we have something like this, though? Say we have x squared plus y squared equals 4, okay? What is the graph of that equation? What is the shape of the graph of that equation? It's a circle, right, with a radius of 2, all right, centered at the origin. That would be what that is, okay? Is that a function? No. All right. So we really, you could solve that for y, but you're going to get two different functions if you do that. You can get the top and the bottom part. But we still would have a tangent line at, say, that point right there on it, okay? So what we would do is we would use implicit differentiation to find the derivative of this in order to find the tangent line, okay? So, again, that's what implicit differentiation is. So any questions about that? So how do we take a derivative of something like that, okay, that we can't really solve for y? That one we could solve, but you have a plus or minus in it and all that. So how do we do it? Okay, well, always in a function, you've got a dependent variable and an independent variable, okay? So if it's y equals something with x in it, then we say y is the dependent variable. It is dependent on what you plug in for x, which is the independent variable, right? So normally, you're going to take the derivative with respect to the independent variable, okay? And that's what we've done up to this point. So if we took something like 2x to the third power, all right, and I'm going to take that, I'm going to say, what is the derivative with respect to x of that, okay? What is the derivative of 2x cubed? 6x squared, all right? There you go. That's it, okay? What if I were to say, well, what if I have y to the second power? And I want to take the derivative with respect to x. Okay, well, what is that going to be? Well, let's back up. What if you have take the derivative with respect to x of y? What does that give you? Well, that is just the derivative of y with respect to x. dy dx, y prime, either way, you can write it, okay? If I have this, I really have a function inside a function, right? Because what would be the big outside function in this? It would be the squared, right? So it's like I've got the big outside function would be the square. What is the inside function here? Y. So if I take the derivative of y squared with respect to x, then first I'd have to take care of the exponent of 2 on the outside. So I would say this is going to be 2y to the first power. What does chain rule say? You take that, then you multiply by the derivative of the inside. What is the derivative of y? Well, the derivative of y with respect to x is dy dx. So the derivative of y squared with respect to x is 2y times dy dx. Okay? It's just chain rule is all it is. Okay? Now, the notation, you can use either this dy dx notation, and what I think I've got my problems worked out here, I'll just kind of alternate back and forth, or that is the same thing as y prime. Okay? This you could write like this, or you could write 2y times y prime. They're the same thing. Okay? When we get to the related rate problems at the end of the chapter, the word problems, it's going to be important to think about what you are differentiating with respect to, because on those we take the derivative with respect to time. So for those, it's going to be important that we do use this notation and we kind of understand what it's talking about. Okay, so we don't want to just throw this out and just use this all the time. Okay, but I do want to use both. So we'll kind of go back and forth on these problems. So any questions so far? All right, well, let's get started with the problem then. Okay, use implicit differentiation to find dy dx. Okay, and then B, find the slope of the curve at the given point. So that's really the slope of the tangent line at that point. Okay. All right, so let's say we've got x to the fourth plus y to the fourth equals 2. Then we got the point 1, negative 1. All right, now this is definitely not a function, right? If you try to solve that for y, you're going to have a plus or minus of a fourth root, all that in it. So, but we want to differentiate implicitly. So what I'm going to do, first thing I'm going to do is I'm going to go ahead and write this first step out. And I'll go ahead and do this probably for most of them. When we get toward the end, I may back off of doing this. But what we do is we take the derivative with respect to x of both sides of the equation. Okay, so we take the derivative with respect to x of both sides. And all of these problems, I think, are x and y. X is your independent variable, y is your dependent variable. Okay, so normally with implicit, that's how it is on all of them. So there's no question about, we always differentiate with respect to x. Okay, so on the left, notice we've got a sum, right? So if you've got a sum, you just take the derivative of the first one plus the derivative of the second. Okay, so the derivative of x to the fourth, what is the derivative of x to the fourth? 4x to the third. And then I don't have to multiply by the derivative of x with respect to x, because what is the derivative of x with respect to x? 1, which doesn't change anything, right? So I don't have to worry with it there, okay? But now this one, when I say plus y to the fourth, then that again would be 4y cubed. But then if I multiply by the derivative of the inside with respect to x, I have to multiply that by dy dx. Okay? Any questions about that so far? What about the derivative of 2? Derivative of a constant is what? 0. There you go. Okay, so any questions about that first step? Took the derivative with respect to x of both sides. Okay? Now we're trying to find dy dx. What do you think we do now to find dy dx? Solve the equation for dy dx. Algebra. All right? So I would subtract the 4x cubed from both sides. Okay? And then to get dy dx by itself, we'll divide both sides by 4y cubed. And I get dy dx equals negative 4x cubed over 4y cubed. And then that will divide to be negative x cubed over y cubed. That would be the derivative of that function, dy dx. Okay? Any questions about that? What do you notice different about the derivative on this one than the ones that we did in the sections before this? What does this derivative have in it that the other ones didn't? It has a y, right? So if you differentiate implicitly, you probably will have a y in the derivative. Okay, that's okay. All right, the ones we did before this only had x in the part that we really did the derivative on. So all we had in the answer was x's. But now we've got x and y. So if I want to find the slope of the tangent line at this point for this function, then I would just take this. I would say at, let me do this, A part, B part. Can you see? So at the point 1, negative 1, dy dx is equal to, I would have a negative 1 cubed over negative 1 cubed. So the slope of my tangent line at 1, negative 1 would be negative 1. Okay? Whoops. Positive 1, sorry. Positive 1. Okay? So if I were to take point slope form, plug in the point 1, negative 1, and the slope 1, I could figure out the slope of the tangent line of that graph at the point 1, negative 1. Okay? Questions about that? All right, so I'll take the derivative with respect to x, both sides. Okay. And I'll use the prime notation on this one. Okay, we won't use dy dx. Okay, so on the left, if I take the derivative of sine y, so notice the big outside function is sine, inside function is y, right? So the derivative of the outside, what is the derivative of sine? Cosine. So I know I've got cosine y. I gotta multiply times that the derivative of the inside. The derivative of y with respect to x is dy dx, or you can write it y prime, and we'll write y prime on this one. Okay? All right, any questions about that step? Okay. On the right side. Now, the right side just have x's and constants, right? So 5x to the fourth, just use the power rule, that'll be 20x to the third. Derivative of 5 is 0. Okay? To figure out what y prime is now, divide both sides by cosine y. Y prime is equal to 20 x cubed divided by cosine y. Okay, so that is my derivative. Okay? Questions about that? Now, at the point 1 pi, y prime is equal to 20 times 1 cubed over the cosine of pi. Okay? What is the cosine of pi? Cosine pi. Negative 1. All right? Go over here, the x-coordinate's negative 1. All right? So 20 over negative 1, the slope would be negative 20. Okay? All right, so we'll take the derivative with respect to x, both sides. All right, on the right side, first I have, so of course I have a sum, so all I have to do is just take the derivative of the first plus derivative of the second. So x to the 2/3, just use the power rule for that one, all right? So 2/3 x, and then my power, if I subtract 1 from 2/3, that'd be negative 1/3. 2/3 minus 3/3, negative 1/3. Okay. Now this one I've got y. Okay. So here I've got chain rule, really, right? I've got the big outside function is that power 2/3, and I've got y inside. So the derivative with 2/3 would be 2/3 y to the negative 1/3, right? But I got to multiply by the derivative of the inside, which is y. So the derivative of y with respect to x is just dy dx. Okay. Any questions about that on the left side there? What is the derivative of 2? 0. Let's have a 0 here. Okay. So now I need to solve for dy dx. So I would first subtract the x part over. So I would get 2/3 y to the negative 1/3 dy dx equals negative 2/3 x to the negative 1/3. Okay. Now notice I have 2/3 on both sides, and if I divide both sides by 2/3, what happens to those? They just divide off, right? So let's say those go away, right? So that will leave me with dy dx equals negative x to the negative 1/3 over y to the negative 1/3. Okay, and then that's okay, except we don't really want the negative exponents. So to fix the negative exponents, just move the x one to the bottom and the y one to the top. So I would end up with their negative, and it's cube root of y. I mean, if you want to leave it y to the 1/3, that's fine, or you can do cube root of y either way. Let's go ahead and write cube root. Cube root of y over, well, let's don't do that. It was the fractions in the problem. Let's just leave it. 1/3 x to the 1/3. Okay. Questions about that? So at 1, 1, what's the derivative at 1, 1 then? Well, 1 over 1, negative 1. Okay. Questions about that? All right, so first, take the derivative of both sides with respect to x, and I'm going to go ahead and write the cube root y with an exponent of 1/3. So it has an exponent. Okay. All right, so now notice I do have a sum here, but what do I have right here in this first one? I have x times y to the 1/3. So I have a product. So I've got to use the product rule to differentiate this one. Okay. So if I take that first one, x, y to the 1/3, and do the power rule, the product rule, then I would have the first. I could do the first times derivative of the second. So x times the derivative of y to the 1/3 would be 1/3 y to the negative 2/3 times y prime. Okay? So that is the first times derivative of the second plus the second times derivative of the first. Well, what is the derivative of just x? 1, so it's really just y to the 1/3. Okay? So that is the derivative of this first one here. Any questions about that? Okay? Plus y. Okay, so now the derivative of y with respect to x is just dy dx, or we'll write y prime on this one. Okay? Equals, all right, the derivative with respect to x of 10, 0. 0 on the right. Okay, any questions up to that point? Okay, all right, so let's reduce this a bit. Now what we want to do now is solve this. We're doing reducing. All right, so we want to solve it for y prime, right? So get everything with y prime in it on one side and everything else on the other. So I'm going to have 1/3 x, y to the negative 2/3, y prime. I'm going to leave that y prime on the left. Move the y to the 1/3 to the other side. So that'll give me a negative y to the 1/3. All right, so I just moved it around there. Okay. Now how do I solve that for y prime now? Factor out the y prime. Okay. So if I factor out the y prime, I'll have 1/3 x, y to the negative 2/3, plus 1 equals negative y to the 1/3. So I just factored the y prime out. Now I've got y prime times that. So divide both sides now by that, and you will get, let me go up here, y prime equals negative y to the 1/3 over 1/3 x y to the negative 2/3 plus 1. Okay? Any questions up to that point? Now, that would be the derivative. Now, it's not in a very good form, though, because we got fractions inside fractions here. And if you notice this x to the negative 2, or y that is the negative 2/3 here, I'm going to rewrite that like this. X over y to the positive 2/3. Okay, so that's really what you've got. So I really have that there for that fraction, okay? So if I have fractions inside fractions, how do I reduce it and get rid of those? Well, multiply the top and the bottom by the least common denominator, okay? So the only denominator I've got as far as the fractions go in this is 3y to the 2/3 power, okay? So let's multiply the top and bottom by 3y to the 2/3 power. Just multiplying by 1, so all legal and good. So if I multiply the top by 3y to the 2/3, 3y to the 2/3 times this, I would add the exponents on the y's. 1/3 plus 2/3, 3/3, so that'd be just y to the first. So negative 3y over, on the bottom when I multiply this times the first fraction, times the fraction here, the whole denominator cancels. I just have x. And then 1 times that will be 3y 2/3 power. So that would be a good reduced form for my derivative. Okay? Any questions about that? Okay. All right, at 1/8, what is the derivative? All right, well, let's plug it in. So I'll have negative 3 times 8 over 1 plus 3 times 8 to the 2/3 power. Yes. Go. Very good. All right. Okay, so 3 times 8 is 24, so I got negative 24. All right, 8 to the 2/3 power. Cube root of 8 is 2. 2 to the second power is 4. 4 times 3 is 12, plus 1 is 13. Negative 24 over 13. Okay. All right, any questions about that? All right, what do you notice? Anytime you see a y in there, what are we doing every time that we see a y when we do the derivative? You multiply it by what? dy dx, or y prime, right? So anytime you see a y in there, now if it's just a y by itself, then it's just dy dx, right? But if you have y in there somewhere, you take the derivative like normal, but always multiply it by dy dx. All right, let's do some more here. So the rest of these, or at least for a while here, we're just going to find the derivative implicitly. Okay, so not going to do any tangent lines or anything like that, just the derivative. All right, so I'm going to take the derivative with respect to x of both sides. Okay. All right, so on the left, I just have a sum, so that's not too bad. Derivative of sine. What is derivative of sine? Cosine. So cosine x. That's all I need there, right? Now I have sine y. So again, derivative of sine is cosine. So I have cosine y. Then I multiply that times the derivative of the inside with respect to x, which is dy dx. Right? So I have to do dy dx. So anytime you see a y inside a function, it means you have to multiply that times dy dx. Okay. On the right side, I just have the derivative of y with respect to x, which is just dy dx. Okay, any questions? What I do on this one, I think, is subtract the dy dx cosine y from both sides. So I would have cosine x equals dy dx minus dy dx cosine y. So I got all the dy dx's together on one side, everything else on the other. Factor out the dy dx. And then divide both sides by 1 minus cosine y. So dy dx is equal to cosine of x divided by 1 minus cosine y. All right, questions about that one? All right, so we'll take the derivative of both sides with respect to x. Okay. So on the left side, the derivative of sine xy. What is the derivative of sine? Cosine. So I have cosine xy. Then I multiply that times the derivative of the inside. The inside is x times y. So on the inside, I have a product. Okay. So I have to use I've used the product rule to differentiate x times y. Okay. So I'm going to multiply that times the derivative of xy. So to do that, product rule, I'm going to say the first times derivative of the second. So x, derivative of y with respect to x is just y prime. Okay? Plus the second times derivative of the first. Well, the derivative of x is 1. So that's just y. So that's what I get on the left side when I take the derivative. Any questions about that? Right side, derivative of x is 1. Derivative of y is y prime. Okay. All right, so now need to distribute here. So let's write y prime times x cosine xy, so that's that one times the first one. Cosine xy times y, we'll say y cosine xy. Okay. Let's get the y primes together and everything else on the other side. So I would leave that where it's at. Subtract y prime. And then leave the 1 and subtract the y cosine xy. Let's factor out a y prime on the left. Okay. Just divide now. You get y prime equals 1 minus y cosine xy over x cosine xy minus 1. There you go. All right, any questions about that one? Okay, so take the derivative with respect to x of both sides. Notice what we're saying here. This line is really not equivalent to that one. We're just saying that if e to the xy is equal to 2y, then that means the derivative of e to the xy should equal the derivative of x to the 2y. So we're finding the derivative, but we're just saying that the derivatives of the two are equal if those two are equal to start with. So, okay. So now, derivative of e to the xy. What is a derivative of e? E, right. So, derivative of e to the xy is e to the xy. But, chain rule, we got to multiply by the derivative of that inside part, which is the product of x and y. Okay? So I got to take the derivative of xy and multiply times that. I did that over there, right? This is the derivative of xy. First times derivative of the second, plus the second times derivative of the first. So this is x. I'll go ahead and leave it y prime for this one. Okay? So that's your left side there. Right side, I've got 2y. The derivative of that, well, the derivative of 2y would just be 2. But then if I multiply by the derivative of y, means I got to have 2y prime. Okay? Questions about that? Distribute. So I have e to the xy times xy prime plus e to the xy times y equals 2y prime. Again, get all of the y primes on one side, everything else on the other. It doesn't matter which one you move where. On my paper, I moved this to the left. But if you want to move this over and divide, it doesn't matter. Kind of did that. Now factor out your y prime. And then divide. So y prime would equal negative e xy over y over e to the xy minus 2. Okay? That answer would probably be okay. All right? I think my math lab was smart enough to know that would be okay. But you could make it a little simpler by taking that. This is like a negative 1 times this fraction. So you can multiply either the top or the bottom by negative 1. Not both, but one or the other, right? So if I just multiply the bottom by the negative, then I can rewrite that. I can leave the top like it is. And that would change the negative 2 to be a positive and the e to the xy to be a negative. So then I could turn it around and say 2 minus e to the xy, and then you don't have a negative out in the front of that thing. But I think either way would be fine. Mm-hmm.
Where did the x go? Or e to the xy, x right there? Where did that x go when you get to that?
I screwed up. Okay, it should be right here. Yep. Sorry about that. Add that in there. Okay. Any questions about that one? Okay, y'all try that one on your paper. All right, well, let's see. All right, so take the derivative of both sides with respect to x. On the left, I've got cosine of y squared. Okay? Now, that is not cosine squared y, right? The y is what is squared there. So the big function would be cosine. What is the derivative of cosine? Negative sine. So I'd say negative sine y squared. Now multiply times that, the derivative of the inside. The inside is y squared. So what is the derivative of y squared with respect to x? Well, it would be 2y. And then times the derivative of y with respect to x, which is y prime. Okay? So that would be the derivative of cosine y squared. Any questions about that? So now plus, and then derivative of x is 1. So that should be the left side. Okay? All right. Now on the other side, derivative of e to the y. Derivative of e is just e. So I have e to the y. Then I got to multiply by the derivative of y with respect to x. So that would just be multiply times y prime. All right, there you go. Some questions about that step. Again, follow the rules. All right. Yeah, if you don't follow the rules, you're not going to do good. Okay, so. All right, so now on the left side, let's see. Let's just move the 1 to the right and move this to the left. Okay, so that'd be easiest. So I can rewrite this a bit. Let's do y prime times negative 2y sine y squared. And then minus y prime e to the y equals negative 1. Okay. And it's the same steps every time, right? Take the derivative of both sides, and then move all the y primes on one side, everything else on the other. Factor the y prime out. And then divide both sides by that, okay? All right, I don't know what I did there. All right, sorry. There. Now divide both sides, so y prime is equal to negative 1 over negative 2y sine squared y minus e to the y. Okay? Now, I got all these negatives in there. So let's just say if I divide the top and bottom by negative 1, changes all the signs. So I would get 1 over 2y sine y squared plus e to the y. And that's a good answer there. Okay? Any questions about that one? All right, we're getting there. All right, this one. We have a quotient, okay? So we'll do the derivative. We need to do the quotient rule. This one we could probably multiply both sides by y minus 1, and then we could do this one. Well, and we probably couldn't solve it for y. We might could, I don't know. But anyway, we're going to leave it like it is and do the derivative. So the derivative of both sides with respect to x. Okay. On the left, derivative of y with respect to x is d. I'm going to go ahead and write this dy dx on this one. Okay. On the right side, got to have a quotient, so we have got to follow the rules for differentiating quotients. Right? Quotient rule. So it will be the bottom, y minus 1, times the derivative of the top. Derivative of x plus 1 with respect to x is just 1. Minus the top times the derivative of the bottom. Derivative of y minus 1 would be just dy dx minus 0, okay? Over the bottom squared. Okay? Questions about that? Okay, so now multiply both sides by the y minus 1 squared, so I don't have the fraction. Okay, so I'm going to multiply both sides by y minus 1 squared. That will give me y minus 1 minus x plus 1 dy dx. Okay, that looks a little better. Okay. Questions? Now, I have a dy dx on the left. Let's just add the x plus 1 dy dx to the other side. So now I would have this. Now, I would factor out the dy dx. That would leave me with y minus 1 squared plus x plus 1. Okay. And now to get dy dx by itself, just divide both sides. Dy dx equals y minus 1 over y minus 1 squared plus x plus 1. Okay? That's a good answer. Any questions about that one? This one you definitely could not. It has to do implicit to do one like this. Okay, so take the derivative of both sides with respect to x. So I would go ahead and rewrite this one with a power of 1/2. Okay, so take the derivative of both sides with respect to x. All right, so on the right side, we've got a couple of things going on. We've got the big function is that power of 1/2, so I need to take care of it. Then multiply by the derivative of the inside, and I've got a couple of things to do in there. So first, this big power of 1/2, I'd have 1/2 times x to the 4th plus y squared. And now multiply times that the derivative of the inside. Okay? So the derivative of x to the 4th, just power rule, is 4x cubed plus the derivative of y squared. All right, well that's going to be 2y. And then since it's y times the derivative of the inside, which is derivative of y with respect to x, I got to multiply by the y prime on that one. I did not subtract 1 from the exponent here, did I? What is 1/2 minus 1? Negative 1/2. That should be right there. Okay? So that is the left side. Any questions about it? Now on the right side, the derivative of 5x is 5. Right? Derivative of 2y cubed, just the power rule, 3 times 2 is 6. Be y to the 2nd, but since it's y, I'm differentiating with respect to x, I got to multiply by dy dx, which is y prime. Okay? Okay. So I went ahead and there's different steps algebraically you can do, of course. I went ahead and just moved this to the negative 1/2 power to the bottom. So I wrote this as 4x cubed over 2 square root x to the 4th plus y squared. And then I said plus. Now this times the second one. The 2's cancel. So I would have y, let's do this, y over square root x to the 4th plus x plus y squared. And then y prime. Okay, that's what I did. So just distributed, but I went ahead and got rid of that negative exponent, moved that to the bottom. Okay. Now we'll move this over here and move this over there. So I would have, so I'm going to do two steps. I want to subtract the 6y squared y prime and go ahead and factor out the y prime at the same time. So I will end up with this on the left. So just to save some space. Okay, so I've got that on the left. And now here my 4 and my 2 will divide, right? 4 divided by 2 will be 2. So that'll just become 2x cubed over root x to the 4th plus y squared. Okay? So any questions up to that point? Now I would divide both sides now by this. It's multiplied by y prime, and I get this. Okay. All right. Now, I don't need to have fractions inside fractions. That's never acceptable, right? So all you got to do here is just think, well, what is my least common denominator of all my fractions in the numerator and the denominator? Well, the only denominator I've got besides 1 is root x to the 4th plus y squared. So multiply the top and bottom of the fraction by root x to the 4th plus y squared. Okay? Okay, so that will give me then, for a final answer, 5 root x to the 4th plus y squared minus 2x cubed over y minus 6y squared root x to the 4th plus y squared. There you go. Okay. All right, the next couple of problems say, says verify that the given point lies on the curve. It does. When you're doing this on the homework, you may have to somehow plug it into my math lab and show it, but they want you to check it, which you can do. Then it says determine an equation of the line tangent to the curve at the given point. So we want to find, for these, the equation of the tangent line. Okay, and we're going to graph it. I'm going to pull up Desmos over there and we'll graph them. All right. Let's say we've got this one, x cubed plus y cubed equals 2xy to the point 1, 1. Okay. So we'll go over here. I'm going to pull up Desmos. Let's see what this graph looks like. All right, there we go. So that's the graph that we've got. Okay. The point it gave was 1, 1. So notice the point 1, 1 is right there. Right. So the point, you can put it in and see, but it is on there. All right, so we want to know what is the tangent line at this point right here. Okay, so let's do our derivative. All right, so now I'm not going to write dx on both sides anymore. Okay, so y'all are good? Y'all understand what we're doing? Taking the derivative with respect to x of both sides. Okay, so take the derivatives. All right, I got 3x squared plus 3y squared times dy dx. Right over here, I've got 2 times x times y. So I've got to use the product rule on the right. So I'm going to say the first times derivative of the second plus the second times derivative of the first. Okay? So any questions about any of that? That's the main first step there. All right, so now what you can do here, you can solve it for dy dx or not, because what is the question asking for? We don't have directions up here. What did I say the directions were? We're looking for the equation of the tangent line. That's it. We're not looking for a derivative, right? But to find the equation of the tangent line, we've got to have the slope of the tangent line, which we've got to get from the derivative. So why don't we here, let's just do this. I'm just going to leave it like it is. Okay, so I'm going to have 3x squared plus 3y squared dy dx equals 2x dy dx plus 2y. I'm not going to solve it. I'm just going to leave it like that. And I'm going to plug in the point where I'm trying to find the slope of the tangent line. So the point is 1, 1. So every time I see x, I put in 1. Everywhere I see y, I put in 1. So I would have 3 times 1 squared plus 3 times 1 squared dy dx, 2 times 1 dy dx plus 2 times 1. So everywhere I see x, I put in 1. Everywhere I see y, I put in 1. So this will be 3 plus 3 dy dx equals 2 dy dx plus 2. And now that's easy to solve and see. If I just subtract 2 dy dx from both sides, I get 1 dy dx. And then if I've got the 2 and I subtract 3 from it, I get negative 1. So the slope of the tangent line at the point 1, 1 is negative 1. And that's all I really need to know. So if you take this and do all that algebra to get it down to y equals, you still got to plug the numbers in. So for these, I would say just plug it in at this point, because this is all we're looking for, is that number right there, not the function. Okay. All right, so now to do the slope of the tangent line, remember y minus y1 equals mx minus x1. That is our point slope form. That works best when we have a point and slope. Okay, so y minus 1 equals negative 1, x minus 1. So put 1, 1 in for x and y, negative 1 in for m. And little simple algebra there, we see our equation line is y equals negative x plus 2. Okay? I graph that, y equals negative x plus 2. Notice, there you go. All right, that looks like we did good. So we've got, it should be tangent. Well, it's not showing it right there at 1, 1. It should be tangent. Okay? Any questions about that? I want to know, what is the slope of the tangent line for this function at this point 1, 2? Okay? All right, well, let's graph this over here and see what it looks like. Okay? That's what we got. All right? So at the point 1, 2, that looks like you've got that looks like the point is right there. Okay? Do you think our tangent line is positive or negative there? The slope of the tangent line. Looks positive. Looks like it should be going just like this, right? So, all right, so let's see what that would be. Okay, so we got to take our derivative in order to find the slope of the tangent line. Okay, so we'll take the derivative of both sides with respect to x. Okay, so on the left side, I'm going to have to first use the power rule. So I'll have 2 times x squared plus y squared minus 1 on the exponent b of just the power of 1 there, right? Times the derivative of the inside, right? Well, on the inside, x squared, that derivative is 2x. Y squared will be 2y, but then times the derivative of the inside. What is the derivative of y? Y prime, right? Okay, equals. On the right side, I have a product, right? So I need to do the product rule. So this would be 25 over 4 times, and then the first times derivative of the second. So that would be 2y, y prime times x. So that's the first times derivative of the second, plus the second times derivative of the first. So y squared times derivative of x is 1, it's just y squared. Okay, so that is my first step there written out. And that's the main thing right there. I mean, after you get that, kind of really just plugging in numbers and going from there. But any questions up to that point? Again, you got to practice that and got to practice following the rules. Okay. Again, I would not algebraically worry about solving this. Just plug in 1, 2. All right, you got simple numbers. So let's plug it in. All right, so I'm going to have 2 times, all right, x is 1, so I got 1 squared plus y squared to be 2 squared times 2 times 1 plus 2 times 2y prime. On the right side, I've got 25 over 4 times 2 times 2, and then times x, y prime, plus 2 squared. Okay, so let's put numbers in for all of the x's and y's. Okay, let's reduce a little more. So I've got 2 times 1 plus 4. That'll be 5. And then here I've got 2 plus 4y prime equals 25 over 4 times 4y prime plus 4. Okay. So I should be able to simplify it a bit more now. So this will be 10 times 2 is 20. 10 times 4 is 40. Over here, 25 fourths times 4y prime is 25y prime. 25 fourths times 4 is 25. All right, subtract the 25y prime. 40 minus 25, that's going to be 15y prime. All right, and then subtract 20, I get 5. So y prime is equal to 5 over 15, which is 1/3. So the slope of the tangent line at the point 1, 2 for that function should be 1/3. Okay? Any questions about that? Okay. Now, to find the equation of that tangent line, let's take point slope form. Plug in our values and reduce. All right, so y minus 2 equals 1/3 x minus 1. Negative 1/3 plus 2, that'll be 6/3 minus 1/3, that'll be 5/3. That should be our equation of our tangent line. So let's see if that matches with our graph. 1/3 x plus 5/3. All right. Looks like we did good. Okay. All right. Any questions about that? Okay. Next couple of problems. Let's find the second derivative. All right, so the directions say find that is the second derivative, okay? So let's say we've got x plus y equals sine y, okay? So to find the second derivative, we've got to find the first derivative first, right? So I'm going to take the derivative with respect to x of both sides. Okay, so on the left side, if I take the derivative of x with respect to x is 1. Derivative of y with respect to x is dy dx. Okay. On the right side, the derivative of sine is positive cosine, right? So cosine y Then on the inside of that function, I've got y. So I got to multiply by the derivative of y with respect to x, which will be dy dx. Okay? Questions about that? Now I went ahead and moved this one over here. So I got 1 is equal to dy dx, and I factored out would be cosine y minus 1. So that's what I've got. I moved this over here, factored out the dy dx. Okay? Then divide dy dx then is equal to 1 over cosine y minus 1. Any questions up to that point? So that's my first derivative, right? We're trying to find the second derivative. So now, take the first derivative and take the derivative of that, and that is the second derivative. So if I take this and I say I'm going to take the derivative with respect to x of both sides, and I'm taking the derivative of this and the derivative of this. Okay? Now notice on the left, this is something I think when we first talked about derivatives, the notation here. Notice if I take the first derivative and I take the derivative with respect to x, where this notation come from, it's kind of like you've got d times d is the d2, and then dx times dx, the x is where they put the square. So that's kind of where they get the notation, but that's what the second derivative is. It's taking the derivative of the first derivative. All right? On the right side, we have a quotient. So let's take the bottom times derivative of the top, which is 0, minus the top times the derivative of the bottom. So the derivative of cosine y minus 1. Derivative of cosine is negative sine. And then times the derivative of y with respect to x. And then minus 1, the derivative of that is just 0, right? So I'm going to write that in. Over the bottom squared. So if I reduce that, this whole first part here is times 0, so that goes away. So I end up with sine y times dy dx over cosine y minus 1 squared. Okay? And let's do this. Let's write this on the side over here. So I just move that. That's really times the whole fraction there. Now, when you're finding a second derivative, okay, it didn't say this in the instructions. A lot of times textbooks will say in the instructions, write your answer in terms of x and y. Okay, so you normally, when you do a second derivative or higher, which you don't really do that, but you don't want to leave a derivative inside the answer. So notice here for our second derivative, we have a first derivative as part of the answer. Okay, we really just want it to be with just x and y, and that's it. Okay, so what can I do at this point to write my answer with just x's and y's in it? What do you think? Almost there. We just got a few minutes. Well, what does dy dx equal? It equals that right there, doesn't it? Right? So that's dy dx. So when you get the second derivative, you get it reduced, you probably will have a first derivative in it. Just take that and replace it with whatever the first derivative is. So here I would say sine y over cosine y minus 1 squared times 1 over cosine squared y, or cosine y minus 1. All right, that is the derivative, right? Now I can multiply those easy, and that just gives me sine y over cosine y minus 1 cubed. So that would be my second derivative. Okay. So again, you don't want to write a second derivative without with a derivative inside of it. Okay, that's kind of that would be a no-no kind of. Okay? Any questions? I think we'll stop there for today and pick up next time. All right, let's do one more. I just think I have 4 more problems is it. So let's just do these 4. All right, so again, this is also one where it says find the second derivative. And we are differentiating implicitly. Okay. So if we have that equation, all right, then first thing I'll do is take the derivative with respect to x of both sides. I'll find the first derivative. Okay, so derivative with respect to y. All right, so on the left side I have a sum. So I just take the derivative of the first one plus derivative of the second. So the derivative of e is just e. So e to the 2y. But then I got to multiply that by chain rule by the derivative of what's the inside function there, which is 2y. So the derivative of 2y would be 2, but then I've got y in there as well, so I also need to multiply by y or dy dx. Let's do dy dx. Okay, so that is the derivative of e to 2y, okay, plus derivative of x would just be 1. Okay, on the right side, the derivative of y with respect to x, well, that's just dy dx. Okay. Any questions about that? Collect all of the dy dx terms on one side and everything, and get everything else on the other. So I would have 2e2y dy dx minus dy dx equals negative 1. So move the 1 over, move the dy dx over. So all the dy dx's are together. Now factor out the dy dx. Let me go up here. So I will have 2e2y minus 1 equals negative 1. All right. And now to find dy dx, just divide both sides. So dy dx is equal to negative 1 over 2e2y minus 1. Okay? So any questions about any of that? That is the first derivative. We want to find the second derivative, right? So I need to take the derivative with respect to x of the first derivative to get the second derivative. So taking the derivative with respect to x of both sides. Okay, so on the left, I would just have second derivative. Okay, on the right, I went ahead and just did quotient rule. All right, might as well. So I have a negative there in the front. Quotient rule, I start with the bottom. So the bottom times derivative of the top. So the derivative of 1 would be what? 0. So really that's just 0. Minus the top times derivative of the bottom. Okay, so the derivative of 1 is 0. But for 2e to the 2y, I would have 2e to the 2y and then times 2 dy dx over the bottom squared. Okay. Any questions about that? Any of those steps there? Okay, so notice what I've got here. All right, so this whole thing here is 0. So that really just goes away. All right. I have a negative. If I put the negative on the top, a negative and a negative is a positive. So I really have 2e to the 2y times 2. That would be 4e to the 2y over 2e to the 2y minus 1 squared, and then times dy dx. So I could write it like that, okay? Any questions about that? Now, like I said last time, when you're finding a higher derivative implicitly like this, you don't want to leave a derivative in the answer, right? We have a derivative in there right now, right? All you do is just substitute in. So dy dx is this, right? So just put this in the place of that. So I would have 4 e to the 2y over 2e to the 2y minus 1 squared times, all right, dy dx right here is negative 1 over 2e 2y minus 1. So that will just multiply those together. I have a negative 4e to the 2y over, and notice here I've got 2e 2y minus 1, and then 1 2e 2y minus 1. So if I multiply those together, just add the exponents. 2e to the 2y minus 1 cubed. Okay, and that's the second derivative. All right, the directions say find equations of all tangent lines to the curve at the given value of x. Graph the tangent lines to the given graph. All right, so let's say that we've got 4x cubed equals y squared 4 minus x, okay? And we want to know what are the tangent lines at x equals 2, okay? Now, let's graph that in Desmos and see what it looks like, okay? All right, we get that, okay? So everybody see the graph? So at 2, we actually have a point there at 2, 4, and it looks like a point at 2, negative 4. So we should have 2 tangent lines on this one, okay? Because there's 2 different points at 2. So first, let's find our derivative, okay? All right, so derivative with respect to x of both sides. And I did not multiply the y squared there. You could do that if you wanted to, but I just left it out in the front and just did the product rule. But you can definitely do the differentiation different ways. All right, so on the left, 4x cubed, the derivative would be 12x squared. On the right, I have a product, so use the product rule. So I'm going to say the first times derivative of the second. So y squared, derivative of 4 minus x is negative 1, plus the second times derivative of the first. So 4 minus x times. All right, y squared, the derivative is 2y. And then since I've got y there, not x, I've got to multiply by the derivative of y with respect to x. So I get that. Okay, so any questions about that? All right, so little work here. Looks like I can just move this negative y squared here to the other side. Got that. And then just divide both sides by the 4 minus x 2y. So my derivative then would be 12x squared minus y squared over, and I went ahead and distributed there, you didn't have to, 8y minus 2xy. Okay? So that is the derivative. Any questions about that? Now the question says equations of tangent lines at the curve at when x is 2. So I'm looking, my answer is going to be the tangent lines, but got to have that to find the tangent line. All right, so next I need to know what those points are. Looks like it's 2, 4, and 2, negative 4, but if you plug it in here, all right, then I would have 4 times 2 cubed y squared times 4 minus 2. All right, so that'll be 2 times 2 is 4, 8, that'll be 32 y squared times 2. And then divide, and then take the square root. Y is plus or minus 4. And that's what we said. All right, so I have 2, 4 as one point, and I have 2, negative 4 as a point. Okay? So at 2, 4, I need to take 2, 4 and plug that into the derivative for my x's and my y's and see what my slope of my tangent line is. Okay? So at 2, 4, let's do this. Let me go down here. 2, 4. The derivative is 12 times 2 squared minus 4 squared over 8 times 4 minus 2 times 2 times 4. Okay. That will be 4. Okay. So y minus y1 equals mx minus x1, point slope form. So I have y minus the y coordinate 4 equals the slope for x minus the x coordinate 2. All right. And then just do your algebra there and slope intercept form y equals 4x minus 4. So there's one tangent line. Okay. The other point we said was 2, negative 4. All right, so if I plug that into dy dx, I would have 12 times 2 squared minus negative 4 squared over 8 times negative 4 minus 2 times 2 times negative 4. Okay, so you just got to put those numbers in, see what you get. You should get a negative 4 for that. Okay, for the slope. So slope there's negative 4, so I would again start with point slope form. Y minus negative 4, that would be like a plus 4 then. M is negative 4, x minus 2. So there it is in point slope form. Do your algebra there, and it will reduce to be y equals negative 4x plus 4. So that should be your two tangent lines there. All right. Any questions? All right, let's graph those two on this graph. We should have y equals 4x minus 4. Okay. It's not a function, so we can't. All right, so that looks like we did good there at 4. Okay. Right there. That's sharing that point. Okay. And then the other one, 2, negative 4, right here, we should have y equals negative 4x plus 4. And that would be the tangent at that point. And it looks like we got it right. So any questions about that? All right, next question says, find the equations of the vertical and horizontal tangents of the ellipse. Okay? So to be a horizontal tangent line, what does the slope have to be? 0. To be a vertical, what does the slope have to be? So what's the slope of a vertical line? Remember? No. It's undefined, right? Because you're dividing by 0 if it's a vertical line. So horizontal line, slope is 0. Vertical line, it has an undefined slope. Okay? So we need to remember that. All right, so here's the equation that they gave us. And this is an ellipse. All right, let's graph it real quick over here. All right, there we go. All right, so that is our ellipse. Looks like the horizontal tangents would be where? Right here it's at 0 and at -6. It looks like the vertical tangents should be here around 1 and 3. But we don't just look at it and say, well, that's what we think. We need to show it, with calculus. So let's do that. All right, so we need the derivative of the function. So if I take the derivative of both sides, all right, I'm just going to take the derivative this time. I'll get 18x plus, all right, y squared, the derivative is 2y, but I've got to multiply by the derivative of the inside, which will be, I'm going to write y prime on this. All right, minus 36 plus 6, and then times y prime. The derivative of 36 is 0. Derivative of 0 is 0. So that would be my derivative. Okay. We can go ahead and find it. The algebra on this is not too bad. So I would probably just collect my y prime terms and move the other ones on the other side. So do that. And then factor out the y prime. And then divide both sides. I mean, we're not finding the derivative, but if you could reduce that derivative if you wanted to. You might make it a little. You can divide the top and bottom by 2. Okay. So there is your derivative. Okay. So again, if I want to find horizontal tangents, what has to be true about the tangent line? What does that have to equal to be horizontal? 0. So let's set that equal to 0. Okay. Now, if I set that equal to 0, what makes the fraction 0? When the top is 0 or the bottom is 0? The top. So when the top is 0, that is when it's 0. If the bottom is 0, it's undefined. So here all I really need to do is just say, well, when is the top 0? That will be when x is equal to 2. Okay. Now, is x equals 2? Is that my horizontal tangent? No. X equals 2 is a vertical line. But when x is 2, that is when I will have a horizontal tangent. Okay? So what I would need to do then is take 2 and then plug that back in here and see what I get. Okay? So because that's your x coordinate, so I need to know what the y coordinate is. So let's plug 2 in there for x. So I will have 9 times 2 squared plus y squared minus 36 times 2 plus 6y plus 36 equals 0. All right. So this will be 4 times 9 is 36 minus 72 plus 36. So that's just 0. So I just get y squared plus 6y equals 0. factor out of y. Y is equal to 0. Y is equal to negative 6. Okay? So when y is 0, when y is negative 6, that is when I have the horizontal tangents, and those are horizontal lines. So that would be my horizontal tangents. Okay? Now the vertical tangents are going to be with whatever makes the bottom 0. So vertical tangents. All right, so to find when the vertical tangents are, what would I let set equal to 0? The bottom of the fraction, right? Because when the bottom is 0 is when it's undefined. So if I take this derivative, the slope of my tangent line, whenever that bottom is 0, that is whenever I have the vertical tangent. So I would say y plus 3 equals 0. When y is negative 3, that's where I have the vertical tangents, right? But again, y equals negative 3 is not a vertical line. That's not the vertical tangent. That's where the vertical tangent is at. So I need to take that back to the original function and plug it in, just like I did that one. So I would say I have 9x squared plus negative 3 squared minus 36 times negative 3 plus, oops, sorry, that's not right, 36x plus 6 times negative 3 plus 36 equals 0. Okay? And then that would give me 9x squared minus 36x plus 27 equals 0. All right. And then I could divide both sides by 9 to make that a little bit easier quadratic to solve. And that would be this. Okay. And then that would factor to be x minus 3, x minus 1. So x is equal to 3, x is equal to 1. That should be my vertical tangents. Okay? I think that's what we thought from the graph over there, but now we know for sure that those are correct. All right, so my horizontal tangents y equals 0 is right there on that x-axis. And then y equals negative 6 is the other one down there. All right. And then my vertical tangents, x equals 3, it's right there. X equals 1. Okay. All right, so any questions about that? All right, this one says determine the equation of a tangent line. Okay, so the first thing, we want to find the equation of the tangent line. Okay, and the normal line. Okay, so we'll talk about that in just a minute, what that is. And then we want to graph the two, and that's pretty much it. Okay, so let's do tangent line first, then we'll talk about normal line. So here is the function, or not the function, the relation. This is the point that we want to find the tangent line and normal line at. Okay? All right, so let's take the derivative of both sides with respect to x. Okay? Now, left side, we have an outside function is that power of 2. Inside function is x squared plus y squared. So we've got to do chain rule, take care of the outside first. So I would say 2 times this, subtract 1 from the exponent, so that'll be 2 x squared y squared to the first power, right? Now multiply times that the derivative of the inside. That's chain rule. So derivative of x squared would be 2x. Derivative of y squared is 2y, but now multiply by the derivative of y, right? So let's do y prime there. Okay. On the right side, let's do 25 thirds times, that'll be 2x, 2y, y prime. Okay. So any questions about that? Now, that's all I would do there, because like we did, I think we did a problem last time where there's no reason to really solve that for y prime. That's going to be a bit of algebra there if you try to solve that for y prime. There's no reason to do that because we're just looking for the tangent line. So all we need is the slopes. It's easy. This will be easier to solve if we take 2 and negative 1 and plug it in for x and y, then solve it, rather than solving for y prime first. Okay. If it asks for a derivative, then you would need to solve. But since it doesn't, let's just say at 2, negative 1, and then let's just plug in the numbers there. So I would have 2 times x is negative 1, y is 2, let's see, 2, okay. Now that will give me, this will be 5 times 2, that will be 10 times 4 minus 2y prime equals 25 thirds times 4 minus 2y prime. Okay. And it's a little bit of algebra. This is algebra 1 right here, right? So just solve this now for y prime. You will end up with this. Y prime equals 2 over 11. Okay, that's what you should end up with there. Any questions about that so far? So the slope of the tangent line at 2, negative 1 is 2 over 11. Okay? So, to do our tangent line, then we will do point slope form. Y minus negative 1, so that'll be y plus 1, equals 2 over 11, x minus 2. And then normally we put it in slope-intercept form. That would be y equals 2 over 11, x minus 15 over 11, if you put that in slope-intercept form. All right? So that should be our tangent line. Any questions about that? Now, what is normal line? Have you ever heard that before, normal, in math anyway? You probably haven't yet. All normal means is it's the same, really the same as perpendicular. It means you've got a right angle there. So it's perpendicular to the tangent line. Is that so? So you're going to see the word normal. You'll hear the word normal again. Perpendicular, normal, orthogonal. All those three words all really just mean at a right angle. Okay? So if my slope is 2 over 11 here, what would the slope of the line perpendicular to that one be? What would my slope be for it? Again, that's back to algebra 1. Remember that? Anybody? A slope that is perpendicular means you would take the reciprocal and change the sign. So if it's 2 over 11, a slope of a line perpendicular to that one would be negative 11 over 2. So, normal line, I would again start with point slope form. Same point, so I got y plus 1 for the slope, though I'm going to put negative 11 over 2. And then x minus 2. Okay. Again, do your algebra there, and you will get y equals negative 11 over 2x plus 10. That would be your normal line there. Okay. Questions about that? All right, let's graph that. All right, so the function we started with, x squared plus y squared squared equals 25 over 3 times x squared minus y squared. Okay? All right, so that's what we got. All right? Make it a little bigger. All right, our tangent line at the point 2, negative 1. So right there, it won't let me show the point, but anyway, right there, our tangent line should be y equals 2 over 11x minus 15 over 11. Okay, that looks right. Okay, and then our normal line we said was y equals negative 11 over 2 x plus 10. Okay, so the normal line and the tangent line, you have a right angle right there at it. Okay. Any questions about that? All right, that is implicit differentiation.